Alright, I'm going to show you how to do this FRQ question. You, at this point, have all the knowledge you need to be able to do this. Now, a 10-point question like this should take approximately 20 to 25 minutes to complete if you're doing it on the AP test. Hopefully, I can answer or figure out or tell you how to answer this in less than 25 minutes. It says, a student is given the task of determining the molar concentration of CuSO4 solution using two different procedures, precipitation and spectrophotometry. The precipitation reaction, the student adds these two reactants together in a white precipitate forms. The student filters the precipitate, dries it overnight, and the data is given in the following table. So the first thing we're going to do is write a balanced net ionic reaction for the reaction between barium nitrate and copper sulfate. Now both of these reactants are aqueous, and the two products that are formed are barium sulfate and CuNO3 2. Because I know that the copper is a +2 charge and the nitrate's a -1 charge, so it's CuNO3 parentheses 2. Now of those two products, the nitrates are always soluble, so the copper nitrate is soluble, and the barium sulfate must be the precipitate. Now I have enough information to write the net ionic reaction. The copper is soluble on the left and on the right, and the nitrate is soluble on the left and the right. So the only things that don't dissolve are the barium ions, the sulfate ions, and of course the precipitate. So down here, the balanced net ionic reaction is Ba2 plus SO4 minus 2 gives you BaSO4 solid. Next, it asks me to calculate the number of moles of precipitate formed. Now in order to do that, I need to figure out how many grams of the precipitate was formed and then use the molar mass to determine the number of moles. So up in the data table, you'll see that I have the mass of the filter paper and dry precipitate is 1.136, and the mass of the dry filter paper is 0.764, so I need to subtract these, and I get 0.372 grams of the precipitate. Now the molar mass, which we will have to calculate, is barium plus sulfate, Ba plus S plus O4, and that molar mass is 233.4 grams. Now I just simply divide these two, and I get an answer of 0.00159 moles of BaSO4. So next it asks me for the molarity of the original CuSO4 solution. Now if you look at the balanced chemical reaction up here, which it's balanced as is, everything's in a 1-to-1 mole ratio, then if I know the moles of the product that were formed, then I know the moles of the reactant because they're in a 1-to-1 ratio. So 0.00159 moles of BaSO4 results from 0.00159 moles of the CuSO4. Now to calculate molarity, I take the moles and divide by the liters, and the liters are 50 milliliters or 0.0500 liters, and the molarity is 0.0319 molar. Next we're on to page 2. It says, for the spectrophotometry experiment, the student first makes a standard curve. The student uses a 0.1 molar solution of CuSO4 to make 3 more solutions of known concentration. It says, calculate the volume of 0.1 molar solution needed to make 50 milliliters of 0.05 molar solution. In order to do this, we need the dilution formula, which is M1V1 equals M2V2. My M1 is my higher concentration, which is 0.1000 molar, and I don't know how much I need of that, so that's my unknown. Now I set that equal to the second molarity, which is less concentrated, 0.0500 molar, and I multiply that times the volume of which I need is 50 milliliters. Now I solve for x by dividing by 0.1 on each side, and my x, or my volume, is 25 milliliters of the 0.100 molar solution of CuSO4. This next part says we need to briefly describe the procedure that the student would follow in order to make the 50 milliliter solution of 0.05 molar CuSO4 using the concentrated stock solution, a 50 milliliter volumetric flask, and other standard lab equipment, assuming all the safety precautions have been taken. Now the first thing you should do is you measure out your 25 milliliters of the 0.100 molar using a graduated cylinder. You don't just do it in a beaker, you do it in a graduated cylinder because that is a more precise instrument. Now you deliver that 25 milliliters into a volumetric flask, and then you add water up to the line. Now what you don't want to do is add your water up to the line first and then add your stock solution in, because then your total volume is going to go past the line. And so on this question, on the AP test, it was worth 2 points. 1 point was for measuring the stock solution first, and the second point is for adding water in the last step. Now we're on to the last page. What you see is the standard curve. Now these are the 4 solutions that we made on the last page, and they put them into the spectrophotometer and measured their absorbance versus their concentrations. And so you can see that the dots all fall in relatively straight line. Now let's take a look at this. Letter F, it says the absorbance of the CuSO4 solution of an unknown concentration is 0.219. Now remember, absorbance is a unitless value, so it's just a number, 0.219. Determine the molarity of the solution. Now you could do this one of 2 ways. You could do this first by simply finding a straight edge and taking the absorbance, which is about 0.219, or about a quarter of the way between 0.2 and 0.3, and you take the straight edge and you draw it straight over where it intersects the line, and then you drop the vertical down the middle and determine what the concentration is using the graph. By using this method, I estimate that it's about 0.035 molar. The next thing you could do was actually find 2 points on this line that intersect known values. So I'll use the origin, 0, 0, and I'll go all the way over here where the concentration of 0.0800 crosses the line at 0.500 absorbance. And I'll do your old rise over run, and I'll calculate the slope of the line, and then I'll do y equals mx plus b to figure out the exact concentration, where the concentration, in this case, would be my variable for x. So if it rises 0.5 and runs 0.08, well then I take 0.5 and divide by 0.08 and I get 6.25. That's the slope of my line. That's my m. Now I input 0.219 for my y because that's my y variable, and the y-intercept is 0, so just 0 for b, and I simply solve for x. And if I do, you'll figure that the actual concentration is 0.035 molar, which is exactly the same as what I estimated it would be using the graph as my guide. Now, I want to note that both are acceptable as long as you explain yourself. Either show your work using the math or simply explain how you use the graph to extrapolate what the concentration would be. It doesn't say calculate what the concentration is, it just says determine the concentration. So if I were you and I were going to run out of time maybe and I don't want to do all that math, I would, in this space down here, just write, I think the concentration is 0.035 molar because I used the graph to figure out where the absorbance of 0.219 is equal to the concentration. Now let's finish up this problem with letter G. A second student performs the same experiment. There are a few drops of water in the cuvette before the second student adds the CuSO4 solution of the unknown concentration. Will this result in a CuSO4 concentration for the unknown that is greater than, less than, or equal to the concentration determined in part F? Justify your answer. Now, if there's a little bit of water left in the cuvette and you add the unknown in, well then that bit of water is going to dilute the concentration. And so, as a result, your absorbance will go down, which will result in a lower concentration. I've seen questions like this on the AP test and some practice AP tests in the last couple of years. And usually it is asking you about some of the data points on the standard curve. For example, this one is slightly above the line, and they'll ask you, account for why this data point is slightly above the line. Now, if the data point is above the line, that means it has higher absorbance than the rest of them, maybe. And so you'll say something like maybe there was a fingerprint on the side of the cuvette, or there was something in the cuvette, maybe something stuck to the inside that would increase the absorbance, because anything that's on the cuvette or inside the cuvette could absorb light and cause an increased absorbance. And anything that's inside the cuvette that maybe dilutes the concentration, like extra water, might mean that the data point is below the standard line, like this one way up here, and you would say account for the fact that this one is lower than the rest of the others, and you would maybe say something like that there was water left over in the cuvette, which would dilute the concentration and throw off the standard curve. So watch out for those because they like to add questions like that on the AP test when it comes to spectrophotometry. Anyway, I hope this little video answer key was useful for you. Thanks for watching.